My name is Dan Reed. I'm the Vice President of Sales and Business Development for Lewis Allis Specialty Motors located in Warrior, Alabama.
Hey, I'm Zach Sloan. I'm a project manager here at Lewis Allis, and we're here in the winding department taking a look at our 2,500 horsepower segmented stacked stator core.
What you see here in the background is one of our specialties in what we call building a legacy motor. We can take a motor design that is either obsolete or something that has been built a long time ago that nobody supports, and then what we can do is we will then be able to duplicate that design, form, fit, and function, and have a drop-in replacement for a customer for a critical application. So a lot of customers come to us and say, I can't get this anymore, what can you do? In this particular case, this is a 2,500 horsepower motor that is being built for a large compressor application, and this customer could no longer get this specific motor made by the original manufacturer. We were able to take it, design it, and provide a form, fit, function drop-in replacement for their process to keep them moving, and it keeps them from spending extra cost on infrastructure and things that they would need with a new motor. That's a specialty service that only Lewis Allis offers to the market, and something we're very proud of.
Here in the winding area, what these guys are currently working on are these tie-offs for this large stator core. We're looking at about an 84-inch ID segmented lamb stacked core. Most of these parts were brought in outsourced and then brought in here to the wind shop to be stacked and then wound with these B-stage form coils. Just due to the size of this thing, we did not have the ability in-house to be able to VPI this core, so that's why we went with the B-stage epoxy-based coils. Out here on the edge are these large press plates, and then that's actually what is tying all of these lambs and pressing these segmented lambs in together, as well as aligning the lambs. B-stage coal stacked into those slots, of course, and then top sticked in. Our winder's doing a great job on that. And then, like I said, as they're going through and then tying off all of the form coils on the ends. Looks like our winding techs are gonna finish up this job in the next day or so. And then we're gonna move on to actually taking this. It's actually already located in the frame that'll be mounted to the base, which is in another area. And once this frame is mounted on the base, we will then take the rotor, which is next door in another area of our facility in our rotor department, and we will actually float that rotor, stacked rotor assembly into this frame to start the full assembly of the motor itself. Over here in the rotor department, what we're looking at here is our in process but stacked and pressed on the shaft rotor assembly for our 2,500 horsepower build that we're doing. Behind me, what you're gonna see is a roughly 7-foot shaft with a spider pressed onto that. And then what we're doing now is they've stacked the lamps on top of that, and they are currently in the process of inserting the rotor bars into these lamps. What that process kind of entails is that we get the shaft, and then the spider came as a separate machine part that is then pressed onto the shaft. And once that happens, then it is flipped up, a press plate is put on, and then we start stacking the segmented lambs onto the spider. Once that happens, the other press plate goes on the back side. Those are then torqued down with the lug nuts you see behind me. And then once that's a completed assembly, we go in and we start inserting the rotor bars and driving those home, and then that's what you see in process. As we saw next door with the stator, that's obviously 84-inch ID. That's not including the OD of the stator itself plus the frame. This being on a 7-foot shaft, obviously a large rotor has to go in that stator, and that stator frame also having to be mounted to the base it can be a challenge. What we do have here at Lewis Allis is a lot of lifting capabilities, whether it be cranes or large lifts, and what that allows us to do is manipulate these stacked and completed assemblies into that final component. So what we will actually do for this large of a build is we will actually section off a piece of the building, move a crane to that end, and designate that crane to be able to lift that frame up onto the base, dowel pin and mount that home, and then float this rotor into that frame before we mount the pedestal bearings and really start assembling that unit.